This is also a fairly straightforward step. We're just plotting everything, and this might look kind of intimidating, but it's really not. We're storing our plots into different different names. So overall plot is storing the overall effect size and its subsequent plot. So ggplot, so this is the function we need, ggplot, and it has many parameters just to make the plot look however you want. And we're using the final data set. AES just specifies what variables we want to use or what row we want to use. So overall means that we're using, so let me go to final. Overall means that we're using this row, and we're using effects1, meaning within the effects column, this value. Geombar position, geombar basically specifies that this is a bar plot. Position equals dodge is just a default to make everything look nice so that things aren't overlapping. And stat equals identity, so it'll assign, like if you have multiple bars, it'll assign each of them different colors based on their x value or x name. So this is our error bar, and we want our error bar to be centered at overall, which is this, and we wanted to go to the bottom at our lower confidence interval and go to the top at our upper confidence interval, and that's effectively what this does. So y min at the lower confidence interval, y max at the upper, with a width of 0.2, color black. So this basically just modifies our error bar. It's a black color, width of 0.2, so it's easy to see. Alpha equals 1.0 makes it not transparent, and this is the size of any text we want. Labels, so we're making the title overall effective exercise on anger. We don't need an X label because it's just one bar. It's just a single column saying overall. Y is our effect size in hedges G, so we're specifying that here. And plus geom text, so this adds more text to the top of the bar. So we want n levels for each of them. So we can see that, so for example, as I was showing you here, things with smaller n levels might need a further look. So we want to have this value pasted on top of each bar. So this basically does that. Label equals paste n equals, and then it adds this n level value to each one. Vjust, so this is just vertical adjustment and horizontal adjustment. This adjusts the text however you want, and you probably have to modify these numbers based on how your data looks. So let's run this. Okay, and now we have to print this, and this is our overall plot, and you can see our n levels are here. This is our title, effect size G. You can see each marker here, and this is our error bar. And we can do this for each one. So p-type data, we're slicing final from 2 to 5, meaning we're taking these rows, because these are participant type, children, young adults, elderly, and we're putting that into another table so it's easier to use. And everything is the same as I mentioned before, so let's look at this. And this is just removing that from our environment because it's not needed. And you can see each label, they're all labeled with their x value, as I told you before. So the reason we don't need a label here is because stat equals identity can either assign different colors to each one, like you can make it do that, or you can have it label each one based on their x value. So x equals labels. Oops. Okay, so now we can do the same with medical condition. We're slicing it, plotting it, printing it, removing the unnecessary variable, and we have it here, n equals 18, n equals 37. Okay, so now if we want to display all of the effect sizes of the 9 moderators in an interesting way, we have to use the formattable function, which just makes it look nicer. I guess it's technically not called formattable, it's called format table, but yeah. So this is our list of effects that's being stored into a vector that we're later going to be putting into a data frame. So this is our list of effects, and our effect sizes are here. We have them collected from final. And then mod table is just us collecting them into a data frame that has these columns, list of effects and their effect size. And then this just names each column, moderator and effect size. So we want these intermediate variables to look at which effect sizes are the most significant. So ones which are more green are going to be more significant than ones which are light green. And we're going to be looking at that in formattable. So this takes our data frame, mod table, aligns the columns. One is going to be to the left, one is going to be to the right. So we're going to have each effect name, each moderator name aligned to the left, and each effect size aligned to the right. So it's just nice to look at. And it's going to be a list in which effect sizes are coded by either light green or green depending on how big they are. So let's look at this. And you can see here that medical condition by far has the largest effect size, followed by gender and duration. So this mostly looks at positive effect sizes instead of negative ones. Like the one with the most absolute effect on anger is medical condition, as you can see clearly here. And the one with the most negative is participant type. And this just removes everything. So now we have all of our plots ready to go. Now, if you wanted each plot, you could just run all of these again. So let's just do that. So now we have all the plots contained over here. And all you have to do is just export or even just copy these into a PDF or Word document, and your poster or study or whatever is ready to go.